After partial and multiple correlations, now we are going into the next topic, that is handling missing values in data. Right now, so far we have seen very many machine learning data analysis, and we have seen that missing values are affecting our accuracy and other parameters of the learning. Right? Why? Because when we train our models, and when many of the data are actually missing, then the model will be biased, and due to that bias, my accuracy will be reduced. So what I have to do is I need to identify what are the missing values. Yes, I have many NA, I have is NA or is empty or is infinite, those kind of methods. And using that, I can identify those missing values. And once those missing values are identified, I need to take some action to handle those missing values. These missing values are actually categorized into two. One is those are actually missing values and not significant, and other are actually most significant values. They were categorized as significant. Why? Because those values which are missing in a significant column of a particular data set are most important to be handled. Rather than if I have a column like, say for example, to be very normal, if I have a serial number like column, and in that serial number, if I miss any values, I don't mean a lot. It is as a missing value, but I don't mean a lot. But if I have something like a column present, like email ID or mobile or age, those are actually important factors. If I consider them for my regression analysis, or if I consider those particular columns for my machine learning analysis, then if any missing values is available in that particular column, then surely they must be handled. So that is handling of missing values. Another thing which also comes along with this is outlier detection. Missing values outlier detection are one of the major preprocessing technique that is most commonly categorized as feature engineering. We always concentrate on feature processing. So once we process the features, we'll be doing predictions, we'll be doing analysis and stuff related to that. But before feature processing, we have something called as feature pre-processing. So in feature pre-processing, we actually handle missing data. We will post some data which is actually not making the model biased. We try to remove outliers from the model. These things we have to do in a particular phase called as feature engineering or feature pre-processing, right? So the most important step in feature engineering or feature pre-processing. Usually, many machine learning scientists or many data analysts will be missing this particular step. This is why they are getting some kind of accuracy mismatches, some kinds of biased models, and so on. This is actually the term which actually make the model biased, and this bias will actually will have a huge impact on the model accuracy. The model will not learn properly when you train it with missing values, outliers, or extremum values. So these three have to be handled. I don't say that it need to be deleted. They need to be handled in such a way that some other values can be given, or they can be removed also. So we have to see how those missing values can be handled. First one. Second is the handling of missing data. Missing data can be of three ways. Number one is deletion. Deletion of missing data. So this deletion by itself comes in many varieties, but there are some drawbacks that will also come when we do deletion. Hope you also know, right? When I have many NA values, and if I try to delete all the data one by one, those are considering having missing values. Then what happens by the time my fraction of data from the whole data sample will be removed. So my original sample, if it is having 1,000 records, after deleting all the missing values, it may reduce to 800 or 750, which actually reduces my training data. So once you have a very large data set, more than required, then you can go for deletion of missing data. Now we will see how those missing data can be handled and how the process need to be done, right? Let's just assume you have some data like here. Let's change the size. You have size f1, f1, f2, f3, and so on. And f1, f2, and f3 are there. For if these are the features, and these features will now correspond to some output. Right now, for this particular data, assume that F1 is actually having some missing data. Say F2 is having a value 10 and F3 is having some value 16, predicting some output 100. So it is having some value like this. Similarly, in the second record, may say F1 is having some 20, F2 is having some 15, and say F3 is having some 20, and the output getting some 200. We are not going to have a proper relation, just we are going to take some sample of data and see how those deletions can actually happen, right? Say it is F2 is going to be 20, and say F3 is having 15, and this is going to be 300, say. And I'll add one more thing also so that we can discuss more on this. Let me just say going to be 30. This is going to be 15, and this is 25, and giving something like 100 or 150. Right? So I'm having some data like this. Now, if you see, I have a value which is actually not available here. That is, this is an NA value. So this NA value need to be handled using some means. Right? So the first step, what I do is keep in mind how important feature one is. Whether feature one plays a most important role in your data analysis or not. That is the first thing you have to keep in mind. If you think that I don't want to think more on my data analysis, then you can directly go for a step called as deletion, where you can delete this entire column just because in this entire column one missing, sorry, entire row, in this entire row one missing value is available. So I can entirely delete this particular feature, right? This way of deleting is called as deleting with respect to rows, row wise deletion. If any one feature in a particular row is actually having a missing data, then the entire row can be deleted. This is actually the first method of handling missing data. But there are some drawbacks in doing this. What is that the most important drawback is, as I said earlier, if you remove data like this, sometimes F2 may have some missing data, and if you need to remove this particular record also, and sometimes F3 may have one, and in between F1 may have another. Likewise, you need to remove as many rows as possible. What will happen is, at last you will be left with some sample size which is actually very much less than the original data size. So that is what's the drawback of deleting the rows. Right? This is actually the first one. Right? Second way of doing it is, assume that I'm having some record here, and I found that F1 is having some missing data. And I also find that after some time of time, F1 is having another missing data, and here also value is available, here value is available, and value is available here. And there are something over here, and I found that there are some missing data here and there for F1. So there are some missing data for F1 and continuous intervals. I have this. So what I can actually do is these tick marks say that these values are available. Dash I mean that the values are not available. I found that many of the F1 data are not available in this particular measure. So in this data set, I found that though F1 is significant, this F1 is having maximum data missing. So what I can do when I feel that this F1's yes. So we are actually dealing with creating a model for missing data, where if I have a particular record that is being missed, then what I will do is, first step is to ignore the target variable. The target variable will be ignored in the model creation. Why? Because this target variable, if I want to understand, I need all the features to be obtained, all the independent features what I consider to apply on this. So if this is missing data, the first thing you have to do in creating a model for missing data is first ignore the output variable. Don't take it into consideration for model creation. Then you could make the missing data. What are the data that are missing as test data? So this will become a test data for me. This will become a test data, and all these will become a train data. All these become a train data. Train data is nothing but those features which are having values without anything missing. So I take those as training data, and I will use these to predict the test data. That what will be the target variable now? Now the target variable becomes F1. because the F1 is a feature which is actually having the missing data. So while we using F2 and F3 features to find what is F1, so I'll be using F2 and F3 to find F1. Right now, there should be a reason for neglecting the output variable. See, if I include the output variable, then what happens is there may be some influence on F1 also on the output variable. The influence of F1 is now being not studied completely, so I cannot take the output variable into consideration. So I just ignore the output variable. I take all the data which is not having any missing values as training data. I'll train the model. I'll get an equation for that, and I'll use that equation to find what is F. Right? I'll use that to find what is F. Now I'll pose a small question to you. Doing this process is an easy efficient process, or is a tough process? This particular thing, that is making a set of data that is having no missing data as training set, creating a model for that, and finding that missing value, which is that, which whether it is efficient or not efficient. So if I whether this particular way of doing the training and then finding this particular value is efficient or not.
So we can get the exact value,
Yes.
very
Great.
near value, sir, but it is highly biased. I mean,
Uh,
biased.
how you say it is biased?
Because we are giving this value based on the output now, sir. That value may be
I
anything, but
ignore. I ignore the output. I ignore the output.
then I think it's best.
Yes, actually, I can say it is an effective model, but not an efficient model. Why? Because if I use the data which is actually having all the variables and without any missing data and use to predict this one, surely this one will have a very good value because I can find a very good value for this. But it is not efficient. Why? Because now I have to find F1 data. Next, something for all the F1 missing data will be, I mean, there may be many F1 missing data. Everything I can be solved by using the equation which I obtained from the training. Then sometimes F2 will be having some missing data during the same set. Then what I should do is I should keep F1 and F3, create a model with respect to F1 and F3 and find F2. Then after some time, F3 may have missing values. I need to use F1 and F2 as training. That those values in F1 and F2 which are not having any missed data, those I have to take and train and use that equation to find F3. So likewise, if the number of features is higher, then you will be in a very big trouble because you need to develop that much models to solve all the India missing values, right? So you can use this particular way because, but if you use like Tanuj exactly said, it is actually very good, right? Because you can get a very good answer for each missing values. But doing this, it is very computationally complex. Computationally complex in the sense when I have more number of features, F1, F2, F3, F4, F5, and I have many missing values. The count of missing values is not that much needed. Why? Because everything is going to be tested data. With single equation, I can find all. But if F1, F2, F3, F4, F5, everything is having missing values, then I need to create a minimum of 5 models to create to find all the 5 feature values. Right. So the entire thing need to be computed in a single model to find output. But to handle missing data with the input itself, I need to find 5 models. So surely it is computationally complex. So when we can recommend to create a model for missing data is when you have a less number of features and a small data set, then you can go for creating a model for missing data. Otherwise, you need not go for this method, right? Right. So now the next one is once we create a model, next we have a most efficient method. The third and last is the best. That is using statistical methods. Right, using statistical methods, we can handle the missing data. So this is actually we consider it as a most efficient way of handling missing data. So what is that method is? What are the statistics you know with respect to data? Can anyone suggest some kind of statistical measures? What are the basic statistical measures we can use with respect to data? Any statistical measures? What is the basic statistical measure?
Mean median mode.
Great. Mean median mode. Very good. So it is actually exactly the same thing what I'm also going to use here. using statistical measures for handling missing data. Like Nitish rightly pointed out, three ways are available. One is mean, and other is median, and the third is mode. Right? So these statistical methods can play a major role in handling missing data. These are actually as effective as possible to give a possibly right option for the value, and computationally easier. Computationally easier also. It will give a near approximate value for the missing data, right? So what is about the mean is replace the missing value with the mean of the proportion. So I'll take mean of the remaining data in the same feature, and I'll substitute that mean into this missing value and solve it. So all the missing data will be replaced by mean of the distribution. So this is one way of handling the missing data by using the statistical measure. That is not just a simple average. I just take an average and use that average to substitute the missing data. What is the next one? What is median is nothing but the middle value, right? I mean the middle value. So what is the range of the entire data set I will see? And if the range is sufficiently higher, then I can take the middle value and pose it to the missing data and handle the missing data. And what is mode? So I can also highest repeated value is a very right definition. I can also say it as frequency, a value which is repeated highest number of times or having higher frequency. I can take and I can consider that value for that missing data. I can say that that missing data, that value can be again coming, so I can keep it that in the missing value data. So these are actually the basic methods. But when you go and apply in the programming, there are wide variety of methods in this mean, median, and mode itself. Why? Because there are something like if I have, say for example, I have age, and I have something like age as one variable, and I want in to my regression method what I take, I age is one of the most important feature. So what I want is, but it is having more missing values, and I need to handle that because only when it is handled, it can be used for my regression model to increase its accuracy. So what I can do is I can take all the age values, and many missing values are there. I can say how many males and females are there. So the thing is, you need not take the mean for all the ages and substitute in the missing values. It is one way, that is taking the mean of the entire data and then substitute in the missing value is one way. The other way is, instead of taking the mean of all the data, you take the mean of the related data called as conditional mean. You have something called as conditional mean. What is conditional mean is, this age is actually going to work together with the gender variable. So you don't take the mean of all the data, you just take mean with respect to a condition that gender is equal to male. So for take the mean of all the male ages and then put it for missing values for the male data, or take the mean of all the female data and substitute for the female data. Why you need to take? Why? Because generally male ages may be higher and female age may be lower or something different in a particular distribution. Surely there will be a variation in the age between male and female. So you can also make something like conditional mean, that one particular variables, this is actually I say it as variable, age variable and gender variable. One variable's missing value can be taken and be handled through its mean based on the condition that other variables have some certain values. Here I say that the missing value in age can be replaced by the mean of all the male genders. So all the when gender is equal to male, what is that? I will take mean of all those ages and I substitute for missing value. So this is the thing, that is conditional mean. Similarly, I can apply conditional median and conditional mode. Right? That is one way of handling that. That is conditional statistical measures, and most properly called as conditional mean. Usually, we don't prefer normal mean. We usually prefer conditional mean only. Right? We don't prefer normal mean. The other way is actually take the, if it is actually temporal data. What is temporal data? Temporary data changing with respect to time. If it is temporal data, what I can easily do is, if I find any missing values, I can directly take the last value in the distribution and substitute. Taking the last value in the distribution and substitute is based on the assumption that it has reached some certainty level, and I can keep that as most consistent and substitute it to all the missing values. That is, take the last value in the distribution. Say, for example, the last value of the distribution is 10 in age. If I have like age is 10 at the last, 20 at the last, I can just substitute it for all the missing values. If it is temporal, I'm not saying it for age, consider it for a temperature or data related to that. If it is like that, you can just substitute the last value and retain it, right? So this is actually called as taking the last data and then substituting for temporal data analysis, right? So I'll just give a quick recap and I'll show a practical way of how these missing data can be handled, right? Just a recap, there are actual missing data is actually the most important feature engineering task or a feature pre-processing task, usually done in three ways. Number one, deletion of missing data. Second, creating a model for missing data. Third, using statistical measures. So deleting the missing data, very computationally easy step. Just to take some features. If it is having some missing data, delete the entire row. If for a particular feature many missing values are available, delete the feature entirely. The problem is, if you are deleting the rows, then the sample size will be decreased. On the other hand, if you are having features entirely deleted, then what happens? Then the characteristic of that particular feature with respect to the output variable will entirely be neglected. So that will be the problem. Advantage is nothing but computationally most easiest way is deleting. It is easily we can do when you want to quickly complete your feature engineering task. Deletion is actually the method. Creating and one more thing I missed in deletion, that is deletion can be advisable only when you have a very large amount of data, that is more than required. If you have the data, then you can do deletion without any further thinking, because you have more data, so this deletion will not affect you much. Then you can easily use the deletion, right? The computational easy step also. Second is creating a model for missing data. This is actually ignoring the output and taking other features which are which are also considered as independent variables, like the feature which is having missing data, creating a model with respect to those features in that what are not missed alone, that alone be taken as train, and other things will be which are missed be taken as test, so that the missed data can now be analyzed and obtained, right? For example, I'll be getting like an equation like f1 is equal to 3x1 2 f2 plus 0.7 f3, like that I may get something. I can get like 2 f2 plus 0.7 f3, like that I may get something. So the f1 value can easily be obtained. So f1 data can be recognized by using this equation. How can I get this equation? I can get this equation through some regression terms. I can use some regression terms and I can get this equation to find the value of f, right? The next, but this method is actually computationally more complex. Why? Because first I have to use f2 and f3 and find f1. Next I need to use f1 and f3 and find f2. Next I need to use f1 and f2 to find f3. So if I have many variables like that, then I need to create models again and again to find those missing data, right? So it is actually a problem when you want every missing data to be analyzed. But the advantage is, when you create a model for missing data and substitute those values for the NA fields, then you will be getting an apt value for your missing data. That is the most effective way of handling missing data. But if you are having a very large data set with many features, then this step is a most computationally complex step and you should not use that. Third is the most preferred step, right? Because it is taking the statistics into play. Though, so I can use the statistic measures like mean, median, mode, the central tendency fields, and I can use the mean of the particular distribution to be substituted for the feature, or median to be substituted, or mode to be substituted. There are also something like conditional mean, where I don't want to take the mean of the entire data. I can take only with respect. I can take data with respect to other values in the particular data set. I will take only the data for which gender is equal to male. That is conditional mean. I can take only the data with respect to the mean for median. So that is conditional median, and conditional mode is also available. Right. So this is actually the ways of handling missing data. Right. Have you understood this? Shall we go into the collab and see practically how this is being done?
Sir, I have one doubt, sir.
Yes.
Sir, for single missing value, we used average, no, sir, for finding and replacing it. For more than one missing value, how can we place it, sir?
You are asking like if you have a missing value like here, you have some data like 20 here and dash here and 6 here and this is 400 like that you are asking, right?
Not only in F2, sir. If F1 is having two missing values, how can we place the second missing value, sir?
All the missing values will be replaced with the same mean.
How uh, how is that possible, sir? Data that will be different, no, sir, for those different missing values.
Yes, but we cannot create a model for each data and then do. If you create a model for each data, then each of the missing fields will be given an appropriate value. Otherwise, we need to substitute all the dash dash here. If you have dash everything, all the dash should be replaced by a common value only. But you can do one thing. You can have a conditional mean also. Like if f2 is greater than a particular value or f3 is equal to a female, like that you can take, and only for those data you can give something. Maybe this and this will be for male records. So for taking mean of these two, you can consider only the fields of males alone. So that alone you can substitute here. And this is for female record. You can consider the mean of all the female ages and substitute here. Like that you can do.
Sir, can we do like this, sir? For first missing value, we find the average and replacing with that, and again finding the average with including the first missing value and finding the average and replacing in second missing value. Can we do it like this, sir?
Yes, and the thing is good, but see the computational complexity of the procedure you are saying. I want to find all the missing values, and for each of those, I need to find again and again. See how many iterations it will go. If the number of missing
But
values is less, it is okay. But if the number of missing values is more, the step is computationally complex.
yeah, okay, sir. Then accuracy for these two methods, which will be the more accuracy, which will give, sir.
Usually, when you use creating a model, when you create a model for missing data, you'll be getting an apt data for all the missing data, and this is most effective method. But efficient, when comparing efficiency, it is actually poor because it is actually taking more time. Many high more time it will take. So, but we cannot go for deletion also. Why? Because if in many real time data set, we will not have more data. If I delete, then my data will be lost. So the best method, which is
Yes, sir.
actually recommended, is statistical measures.
Okay, sir.
Yes, right.